Okay, we have another Ferris wheel problem here, and we've dealt with this thing directly in class. I mean, we've done these, so let's draw a Ferris wheel. It doesn't have to be elaborate. And actually, on the original copy of this, I had retyped it from its original form because it had the words released right across every page. It was really annoying. But it had a diagram of it, so you could draw on that if you needed to. But here's our Ferris wheel, and I put this in here because it looks like a lollipop. And it's obviously a certain distance off of the ground. Ferris wheel has a diameter of 80 feet, so this is 80 feet. So let's go ahead and put that in there. This distance across here, that's 80. And riders enter the Ferris wheel at its lowest point, which is 5 feet above the ground, so that's 5. Obviously, this is not drawn to scale. And they enter that at t equals 0 seconds, so basically when the ride starts. One complete rotation takes 65 seconds, which function models a rider's vertical height at t seconds. So what we need to do is figure out the maximum point, minimum point, all those kinds of things. Well, we already know the minimum point is here. This is where they get on. And we know the maximum point is here. So we need to know what that maximum point is. And you know what? While we're at it, we need to know that height right there. As a matter of fact, let's go ahead and look at our answer choices and see what we have. We have a number in the front, some kind of jumbled up mess here with a 2 pi, and we also have this on the end. And we've dealt with this. So let me go ahead and write down what those three things are. They are amplitude, period, and the vertical shift. Now, I do want to point out, too, that we did not deal much with cosine, and all of these are cosine. So let me go ahead and clear up one thing that confused me a little bit at first before I realized they were all cosine, because I was looking at the numbers and not the actual word there. That negative in the front was bothering me, but that negative is there because it's cosine. And for reasons of, you know, the graph looks the way that it looks. Cosine starts actually at the top. You know, when you would graph a sine function, I'm going to ramble for just a second here, bear with me. But you know, when you would graph a sine function and it would normally start at the origin, unless it had some sort of shift, that was a terrible graph. But it would start at the origin. Cosine starts at the top. And so cosine would do this instead. It would go up here. Well, we're actually wanting it to start at the bottom, and so it flipped it over, and that's why that negative is there. So long story short, that negative is there because those are cosine. Okay, ignore my scribbles. Looked like it was marked out to start with anyway. So let's go ahead and get a few little things out of the way. The amplitude is the distance from the middle to the top or to the bottom. So from this point to the top or from this point to the bottom is, wonder how far that would be. Well, let's see. What's that distance right there? Well, if the whole diameter is 80, then that must be 40, and of course that must be 40 as well. So the amplitude of this thing is 40. Now, please don't turn the video off here and say, oh, well, I've already found the answer. Yes, you've already found the answer, and I'd like to think that you know that it's staring you in the face right now. But I want you to understand where these other numbers come from, because on your exam it may not be so obvious. I'm going to skip this one and come back to this one. Let's go to the vertical shift. The vertical shift will be basically a quarter of the way through the ride and also 3/4 of the way through the ride. And it is, distance-wise, it's the halfway mark between the minimum and the maximum. So the question really is, how far is this above the ground? Well, if you look at the appropriate numbers, it's 40 and 5, so it must be 45. So the vertical shift is 45. Okay, again, you know the answer, I know the answer, it's staring you in the face. I'll go ahead and tell you it's B. But I also want to explain what this is and where it comes from. Okay. Where is it? One complete rotation takes 65 seconds. So the 65 is built in here, and here, and here, and here. But the period is determined when you're in degrees, and we're in radians, because that's 2 pi, that's not 360. Okay, let me pause what I said right there, and let me clarify. 360 degrees is the same thing as 2 pi radians. 2 pi being approximately 6.28. So we are in radians, we're not in degrees. But for just a second, let's talk about degrees. This part of the equation right here is the way we determine the period. And it's going to be 360 degrees divided by the, in this case, it's going to be the rotation speed. Rotation speed. I just turned that all into one big word, rotation speed. 360 degrees divided by the rotation speed, and that would give us the period. Well, again, we're not in degrees, we're in radians. So it's going to be 2 pi divided by the rotation speed. Okay, if that didn't make much sense, let me clarify just a couple quick things. Again, we're in radians because it says 2 pi. How do I know, just looking at this section right here, how do I know that these two are wrong? Because it's upside down. It's going to be 360, or the equivalent, 2 pi, divided by the rotation speed. And this one is upside down, and so is that one. So I know it narrows it down to these, if we're just looking at those parts. So again, obviously we know the answer is B, but because this is the amplitude, this is the vertical shift, and that right there is the way we determine the period. And we take a complete circle, which would be 360 or 2 pi, and divide it by the rotation speed, and that would give it to us. And they just left it as a fraction.